Unit 4. Complex salts or coordination compounds. In inorganic qualitative analysis, you are given single salt and it should be water soluble. Suppose aqueous solution of KCl is given to you, then you have to identify positive radical K plus and negative radical Cl minus. Detection of negative radical. For that you have to add AgNO3 in original solution. If white precipitates obtained, which will be of AgCl, then you have to add NH4OH. If precipitates immediately dissolve, then Cl minus ion is present. Detection of positive radical. Analysis of 5th B group. K plus is present in 5th B group, so we have to carry analysis of 5th B group. Original solution plus sodium cobalt nitrite solution. If yellow precipitates obtained, you can say K plus or NH4 plus ion may be present. Then original solution plus picric acid. If you get yellow precipitates, K plus is present. Aluminium sulfate. It gives Al plus 3 and SO4 minus 2. Aluminium plus 3 is present in 3rd A group. For that you have to add NH4Cl and NH4OH. If white precipitates obtained of aluminium hydroxide, you can say Al plus 3 is present. For SO4 minus 2 you have to add either barium chloride or barium nitrate solution. And if white precipitates obtained, you can confirm the presence of SO4 minus 2. Now if two salts are mixed like KCl and aluminium sulfate, this mixture is known as double salt. And in this case, you have to identify 4 radicals, 2 positive, 2 negative. So on addition of picric acid, if you get yellow precipitates, you can say K plus is present. On addition of ammonium chloride and ammonium hydroxide, if you get white precipitates, confirm the presence of Al plus 3. On addition of barium chloride, you will get white precipitates. On addition of AgNO3, you will get white precipitates. So this way you can confirm SO4 minus 2 and Cl minus. That means in this mixture, all radicals can be identified and they are not losing their original characteristics. So this is known as a mixture and it is known as double salt mixture. In case of KCN, we have to identify K plus and Cn minus. If picric acid is added, you will get yellow precipitates that confirm the presence of K plus. On addition of AgNO3, you will get white precipitates which are insoluble in NH4OH, therefore Cn minus is present. If ferrous cyanide is given, we have to identify Fe plus 2 and Cn minus. On addition of NH4Cl and NH4OH, if you get green precipitates, it confirms the presence of Fe plus 2. And if you get white precipitates in AgNO3 which is insoluble in NH4OH, then Cn minus is present. So, if you mix KCN and FeCN twice, then we have to identify 3 radicals because Cn minus is common negative. On addition of picric acid, you will get yellow precipitates. But on addition of NH4Cl, NH4OH, you will not get green precipitates. On addition of AgNO3, you will not get white precipitates. That means Fe plus 2 and Cn minus are not giving their characteristic reactions. So they lose their characteristics. So if you mix KCN and FeCN twice, this is no more a mixture, but it produces another compound which is having typical behavior in which you cannot identify all positive negative radicals. so it is known as complex salt. This is coordination compound. Now how coordination compound is formed? What is complex salt? So let us take ferrous sulfate. Ferrous sulfate dissolve and give Fe plus 2 and SO4 minus 2. This is known as dissociation or ionization. Fe plus 2 is surrounded by water molecules. SO4 minus 2 surrounded by H2O molecules. Fe plus 2 is attracting O minus. SO4 minus 2 attracting H plus. And this is known as solvation. You will find around 6H2 around 1 Fe, about 1 Fe plus 2. And 6H2 around 1 SO4 minus 2. Now Fe 26. 36 4S2 4P. Fe plus 2. 36 4S0 4P 4D. Fe plus 2 is smaller in size than Fe. Plus it has empty orbitals. Fe plus 2 is Lewis acid and water is Lewis base. So Fe plus 2 accept electron pair and these empty orbitals gain electron pair from H2O. So each oxygen accept electron pair, each oxygen donate electron pair to Fe plus 2 and form coordinate covalent bond. So here Fe plus 2 accept total 12 electrons from 6H2O. In this case, coordinate covalent bond is directional, so there will be hybridization, and hybridization of Sp plus 2 is sp3d2. Number of bonds are 6, angle 90 degree, so shape is octahedral. So Fe plus 2 accepts 6 electron pair from 6H2O, so this is the shape of FeH2O6. Oxidation state of this complex is plus 2. So if you want to write this as reaction, then in aqueous solution, Fe plus 2 react with 6H2O. In this case, Fe is in the center, so it is known as central metal ion. It accepts electron pair, so it is Lewis acid. Water is neutral molecule, but it donates electron pair to Fe plus 2 and it is Lewis base. And it is known as ligand. This box bracket is known as complex ion. When you put anion outside box bracket, then it is called complex salt. In any complex salt, you will find central metal and neutral molecule or negative ion as ligand. There will be coordinate covalent bond between ligand and central metal. Now this is one complex ion. If it is positive, then there will be negative ion outside this, and cation and anion form ionic bond. So there are two bonds in complex. One is coordinate covalent bond, another is ionic bond. And overall it is called coordination compound. So in coordination compound, you will always find box bracket. There is always central metal, there is always ligand. If complex ion is positive, there will be anion, an ionic bond between cation and anion. When you dissolve water in water, ionic bond is broken. So anions and complex ion is separated. But you cannot separate central metal ion from ligand. Why? Because it is coordinate covalent bond. When KCl and FeCN twice were mixed, it formed complex, and that is K4FeCN6. In this complex salt, Fe is central metal, cyanide is ligand, it is negative ligand, so overall valency of this complex ion is negative, it is -4, therefore we need cation. There is coordinate covalent bond between Fe and Cn, and this is negative ion, so cation form ionic bond with anion, and this is complex. Now in this complex, Fe is central metal, cyanide is ligand. And when you dissolve this complex in water, 4K plus will be separated, but FeCN6 minus 4 ion remain together. And you cannot separate Fe from Cn or Cn from Fe. And when they are together, The identity of Fe is different, Cn minus is different, and therefore you cannot get any characteristic reactions of Fe plus 2 and Cn minus, because you cannot separate them in aqueous solution. So this is complex salt.